Our talk is about running Elixir on the edge and, well, what we learned with that. And basically nothing. We learned nothing, just use Python instead. Kidding. Of course not. Let's not forget about global lock interpreter from Python. Let's leverage Elixir use cases, right? But before we start, let's talk a little bit about us because we're really cool people.
Yeah. I'm Paulo. I'm an electronics and computer engineer. I work as a software engineer at TV Labs, and I'm part of the NX core team.
And I'm Vittoria. Formerly, I'm a control and systems engineer, but right now I work as a software engineer at Driver Technologies, and I am currently in a computer vision master's program. So how we ended up here, how it all started. Last year, I was at ElixirConf US, and Paulo gave a talk about running NX, the numerical Elixir library, on edge devices, using Livebook and Nerves. And why Livebook? Because he used a lot of examples using mobile devices. And I was like, I have something in my pocket, and I would love to connect that. I would love to leverage Elixir concurrency powers to run machine learning inference models, such as NX. So that was his talk about. But my idea is because I had the Raspberry Pi with this AI kit in my office, hanging there, and I was like, I really want to do something that, and it's not Python, please, let's start something with Elixir. For those who are not familiar with the Raspberry Pi, well, Raspberry Pi, I assume that most of you guys are familiar with, but the AI HAT, well, what is that? It's basically acceleration module for the Raspberry Pis that you attach on top of it, and it's basically a high-performance, low-power NPU, which can be as performatic as, for instance, some NVIDIA NPUs. And it's super compatible with the Raspberry Pi. And they also have the Hailo RT, which is their runtime API for interfacing with the NPU. They have Python and C++ bindings, and it's compatible with deep learning frameworks and loads like neural network models. Pay attention to that, pre-compiled to this Hailo exchange format. That was a lot of headache.
Yeah, and we first needed to figure out how to actually get the Hailo runtime to be supported in a nerve system. And we built on top of previous work that was started by Lars and Coco and Gus. And we took the state-of-the-art that they had built into a GitHub repository, and we forked that, a fork of a fork of a fork of a fork, and we got a nerve system that runs the Hailo runtime and supports it as a NIF library. So we wrote an Elixir NIFs for the main Hailo functions that we needed to build a pipeline for inference. And then we get a workflow for loading a model and then running the inference on the Pi itself. So for loading a model, we get the AGF path, the path that contains the precompiled model. We instantiate the device, which is a pointer to the C++ object that handles the communication with the Hailo device itself. Then we configure the network group because each AGF file can contain multiple models. And then we create the pipeline, which is what we can then use for the inference itself.
And the other function that we need to have available as well is the infer. And for inferring, basically need to format the NX tensor input into the format that the Hailo expects, which is the vstream input. Vstream input is a way for them to optimize how the processor works. Call the API infer, what Paulo said about the NIFs that we wrote, and then parse the output that we received from the Hailo in as an NX tensor output. Am I missing something? Okay.
Yeah. So for each model, we'll require pre-processing specific to the model, and also output post-processing that's specific to that model as well. And the Hailo models will require different pre-processing and post-processing than what we would get from the standard model itself. So for the YOLOv8 pipeline, that's what we worked with for object detection. We're using Evision, which is OpenCV bindings for NX and Elixir, to capture the webcam, and then we add padding, resize the image to get it into the correct proportions and size for the YOLO model. And then we also use it for post-processing the output that we get to actually draw the bounding boxes onto the input image. And then NX is used not as a library itself, but as a common interface for Evision to communicate with NX Hailo. This is something that I think is really important to convey, that NX isn't necessarily just used as a numerical calculus library. It can also be used as a common exchange format between libraries that talk in different data formats. And yeah, now let's look at our Livebook.
So, well, words are not enough. We will show the code. Basically, we connected the Nerves system in a Livebook, so we could run code as we want, and it would be easier to demo. So this is kind of like how it looks. We have in the project repo the setup for doing that. So basically, we are connecting with the Nerves that has the NX Hailo library. We load the module. Then we need to find the connected camera to the Raspberry Pi, this tiny thing that it's here. You guys cannot see it, but it's here. So we find the connected camera. We need to use CV to give us, like, if it's the open connection, the frame width and the frame height in order to parse our bounding boxes and all that, blah, blah, blah. But then we also need to pre-process the input image. If anyone has ever worked with machine learning for computer vision, so probably they are kind of more used to this pre- and post-processing pipeline that we got to do in order to run machine learning models. But we need to pre-process the input image, especially in terms of resizing the images, and then run it from our webcam, which is the camera that we are using.
Yeah, so we get the current frame as our input image, run the pre-processing, and then the highlighted part here is what I was talking about. We can convert the Evision matrix to an NX tensor, and then the NX Hailo library can understand that struct and extract the data that it needs out of that. And then the Hailo infer function can receive the input data as well as a module for handling the binary output that the framework gives us, and actually outputting things that we can understand in Elixir. And then those things are structs that we defined, and then those structs can then be filtered with that enum reject call that we have down there. Currently, it's not filtering, it's just accepting everything there in the code. You could change that 0.0 to, let's say, 0.5 and get only the things that you're really confident about. And then post-process will also, post-process and draw detected objects will work together to draw the bounding boxes onto the output image, and then, onto the input image to get the output image. And we must thank Alvi Susmel for that. He maintains the YOLO library that's based on an X in Elixir, and he helped us understand the binary output as well as what kind of pre-processing we needed to do to get the proper results. And because we're really bold, we're gonna try for a live demo right now. So let's scroll down here to the Livebook, open the camera, and yeah, we get two people being detected.
One people being detected.
And then if we turn the camera to the audience, we can get lots of people, chairs, dining table.
Chairs and persons. Well,
and this is all running right now in real time with the Raspberry Pi.
It's running like in this device. It's not sharing any video data on the internet. We are not using any API for doing the inference. So we're not calling OpenAI. We're not calling like Cloud API. We don't need to do any pre or post processing on the cloud. It's basically everything self-contained, and it probably costed us less than $150 USD.
And yeah, and we're using Livebook to demo this, but really we could not get the image out of the device. We could just be running things on the device itself. So, hey, the camera is pointing at a section that shouldn't contain any people. And then it detects a person, you can sound an alarm and take action with the Nerves device without having to rely on any external connection. As Vittoria was saying, it's closed circuit, being really closed circuit and not leaking data out of the
You just could have
site.
like an API that would ingest the data from the post-processing pipeline. So yes, that's us.
Yeah.
We made it. For future possibilities, I would say let's have a family of Raspberry Pi clustering, right? And they could all be able to handle that distributed in multiple devices. So let's say you have a warehouse, retail, and you have multiple edge devices on site. You could put all that in a cluster.
Yeah, and then let's say you could wrap everything in an X serving if you just need to do load balancing of the detection, or you could use Handoff, my most recent library, to do something like, hey, I have some devices that have cameras, other devices have the Hailo HAT, and then we can just automatically allocate and grab the camera from one device, the Hailo from another, and then do the data distribution automatically in the local cluster.
And even the processing. So let's say that one Hailo is already 100% of capacity. It could share the processing with another Raspberry with a Hailo HAT attached to it that might be available. Also, it can be applied to any other embedded system, so any type of sensor that you might be using, and you want to run any other type of machine learning inference model. And we also could have more people contributing and engaging, so we can support more Hailo models, and then we could use Elixir on the Raspberry for even further different types of applications. Everything can be seen and found in the GitHub NX_Hailo. Feel free to comment, just nice comments. You cannot complain, especially about Paulo, unless you pay us. And yeah.
Yeah, thank you.
Thank you.
Do we have some questions in the room? Anyone? I can try ask one. Apart from buying this Raspberry Pi and Hailo HAT, what software do you need to put on the to do that recognition? I mean, faces, tables, and stuff. Who does that?
What do you mean? Who?
Which component? I mean, is it software,
so
a library?
We basically have the Hailo doing all the processing, the running our model, and we are just passing data and getting the output of it, but everything is being processed at the Hailo accelerator attached to the Raspberry.
Yeah, and then you can have different AGF files with different models. So we're using YOLOv8, V8M, which is YOLO version 8, M being the size, it's a smallerish model. You could have YOLO11, and then that's a separate pre- and post-processing pipeline that you need. You can go with a totally different application. There are models for audio transcription, models for object classification or segmentation, very different applications, or even if you define an ONNX model, which is like a standard for exchanging data, you can also define your own AGF file using the Hailo RT compilation workflow.
And it also loads multiple models. So if you want to have the Hailo NPU being able to deal with different type of use cases, so object segmentation and object detection, you can load those two models and create two different pipelines, and yeah, use it for more than one use case with a single NPU.
Thanks. Thank you. Let's. Yeah. One more question, Lars. Yeah, sure.
Have you tried running any other types of models on the Hailo? I'm very curious if you could fit a really, really tiny language model or stuff that's not sort of audio or visual. Are there any limitations you see with that?
We went with YOLO because it's more visual. It's like cooler for demoing. But I also experimented with ResNet, which is for image classification. The output is a lot easier to parse, but I wasn't getting very good results, probably because of the pre-processing pipeline that wasn't as fine-tuned, but it was almost there, so for sure other image processing pipelines will work. There are different Hailo chip sizes as well. We're using the 8L, and there are larger NPUs that will handle heavier models. But I do know that the Hailo model Zoo, which contains like their pre-compiled models, has examples for audio transcription, at least.
Yes, and some different, like the Hailo 15, which is like a bigger capacity processing NPU, is not compatible with the Raspberry. So for now, the use case is limited, but like the applicability is now it's just like plug and play. Like load the module. If you are very knowledgeable with machine learning, just as Paulo, like know what to do, all the shenanigans for the pre and post processing, then yeah, it's out of the box because the setup for writing in Elixir is done.
If I go back here, we can see in the infer function, we have the decoder module and then options for that module. And these are like very, very generic. It just takes in the output binary that we get from the inference pipeline, and then options that might be needed for that type of decoding. And then it can output anything as well. So raw detected objects is actually a list of structs defined by this module specifically. It's not specific to the NX Hailo library. It's specific to NX Hailo parsers, YOLOv8. And then YOLOv8 could have a different raw detected object struct. And then the post-process function as well, it's part of that module. Maybe a separate ResNet, the post-processing would just be a softmax activation and then converting to the index to the class name. So it's very, very generic right now, and you can implement your own parsing module and then add your own post-process function.
Thank you.
Thanks again.